Now we've gone over how to create an index, and we have some basic understanding of when an index will be used. But there is a command inside the database, explain, that will tell you exactly what indexes were used for your queries and how they were used. And in this lesson, we're going to go over the explain command. I've created a collection called foo inside the test database that has 10,000 documents. And the documents are pretty simple. They have the structure. They have an A, B, and C key. And you can see here A is 0, B is 0, C is 0. And then I just increment 1, 1, 1, 2, 2, 2, etc. I put an index on this collection. And the index is a compound index on A, B, and C. And let me scroll through and show you that ensure index command. So this was the index that I put on the collection, where there's A, B, and C in the index. And now I'm going to do a query where I would expect that the database could not use an index. So for instance, the query where B was 10 or something. So let's just do that. There's one. We'll do one where C is 1. That is a query where we would expect that the database could not use the index. And we get the result. There's one document that matches that criteria. Now we're going to call the same exact query, but we're going to append an explain on the end, and we're going to look at the result. So I added explain to the end, and now instead of getting back the document itself, we get back an explanation of what the database did to perform the query. Now, the first thing to note here is that it says cursor, basic cursor. Now, basic cursor means that there was no index used to execute this query. That doesn't surprise us because we know that we gave just C, and we know that the index is A, B, and C, so we know that the index couldn't be used, so it doesn't surprise us to find out that it couldn't use the index. Now I'm going to go over a lot of these fields soon, but I just want to bring your attention right now to this millis field, which is the number of milliseconds that was required to execute the query. And as you know, there are 1,000 milliseconds in a second, so this was 3/1000ths of a second to execute this query. All right, that's pretty slow for a database. I mean, if you want to do thousands and thousands of operations a second, that's going to be pretty slow. Now let's do another query, but this time let's have it be A being 1, or let's say A500. I won't go back and get the document because we know there's one in there. I'll just look at the explain output. The explain output is much longer this time. The first thing to note is that it no longer says basic cursor up here. It says that there is a B tree cursor A1, B1, C1 used to perform this query. Now that is the name of the index, the compound index, on A, B, C. So the first thing you note here is that the database is using the index, which is excellent. That's exactly what we wanted. Second thing to note is that is multi-key is false. This is whether or not the index is a multi-key index. None of the values inside A, B, and C are arrays, so it is not a multi-key index. N1 is the number of documents that is returned. This is a simple query where A was 500. There are 10,000 documents in this collection. Is only one of them where A is 500, so it returned the one document. N-scanned objects is the number of documents that were scanned to answer the query, which was the one. The index drilled down, found the one document, and it was returned. N-scanned is the number of index entries or documents, I believe, that were looked at, which again is 1. And then I won't go over some of these, but I want to just point out a few of them. And one is that there's this index bounds element right here. Okay, that's one element I want to point out, which shows the bounds that were used to look up the index. And it's not surprising that we looked up 500, 500, the lower and upper bound of 500 for A to perform that index, and then the rest of them are set to min and max element. Not too surprising. This last field that I want to show you right now is this index only field. And this index only field tells us whether or not the database query could be satisfied with just the index. This is a concept we haven't talked about yet. It's called a covered index. If everything you're asking for can be satisfied with just the index, then the index only field will be true. And then the document itself didn't have to be retrieved. Let's see if we can modify this query to make that true. So I'm going to go back to this query where I look for A500. And this time, what I'm going to do is ask for just A is 500. And I'm going to ask for just the A field and the B field. And I'm going to suppress the underscore ID field and not ask for that. Let's look at that query. Let's run it. We see there's one item. This is a query that should be completely satisfied by the index. Let's call explain and see what we get. And here you can see that now index only is true because we didn't need to go to the actual collection to answer this query. All the information that we needed is in the query. All right, let's look at a slightly different variant. Let's look at a query where MongoDB cannot use the index for finding the documents, but it can use the index for sorting the documents. So in this query, we have an AND clause, and we're looking for C values that are greater than 250 and less than or equal to 500. And we're going to sort by A. Now we know the index is on A, B, C, so it shouldn't be able to use the index to find the documents, but it should be able to use the index to sort them. So let's see what happens when you run that query and hit explain. All right, so what we find out is that 250 documents were returned, which is what we'd expect. And it says that it used this B-tree cursor index, but it didn't use it for the actual find part for selecting the criteria. Instead, it used it for sorting. And the way you can tell is that the number of scanned, this is index or documents, was 9541. Number of scanned documents was 250. So in this case, what MongoDB did, and I'm not positive about this, but I'm pretty sure, is that it scanned the index itself. It only had a look at 9,541 index entries before it felt that it had gotten exhaustively all the documents that were between C250 and C500. And so then it actually went into those 250 documents, and this right here is the number of documents it touched, and then gave us the results. Let's change this around a little bit to make it more clear exactly what's happening here. I'm going to drop this index on A, B, C. And I'm going to add a new index on just A, B. Now we're absolutely positive that it can't use the index values for the find, even if it scans them all. Now we're going to do the same find. Remember, we're looking for C greater than 250 or less than 500. And we have an index on only A, B. All right, but we're asking to sort on A, so it should be able to use the index for the sort part. Let's see what happens. And in this case, the result is more clear. You can see that, again, it returned 250 documents, but you can see the number of scanned index or documents is 10,000, and the number of scanned documents is 10,000. So in this case, it couldn't use the index at all, couldn't even scan the index to figure out what the answer was. So it went right to the collection, it scanned them all, and then it was able to use the B-tree cursor index to return the results in sorted order. And just to show you that this is the index on A and B, I'm just going to show you the get indexes command, which will show you the indexes that are on the collection. And you can see this collection has the index A, B is now called A_B_1 for ascending and ascending. All right, it is now time for a quiz. Given the following output from explain, what is the best description of what happened during the query? And the choices are: the query used an index called basic cursor and returned in 5,151 microseconds. The query scanned 10 million documents, returning 10,000 in 5.2 seconds. The query scanned 10,000 documents and returned in 5 milliseconds. And the query was able to use a covered index to answer the query entirely within the index without looking at the documents.